IoT describes physical objects or groups of such objects that are embedded with sensor, ability, software, and other technologies.
Welcome to the revolution.
Hello, a very good evening to all of you. Hope you are staying safe, healthy, and especially following those proper health guidelines. And I'm Asiramayal, one of your moderators today. And I hope today it will be something awesome to all of you because today and those upcoming weekends will be really important and it will be very interesting to all of you. I think the introductory video gave you some idea regarding this special event. So let me first welcome you, all of you, to the InnovMind on behalf of the Industry Application Society of the IEEE student branch of Sri Lanka Technological Campus. So let's inspire our ingenious minds. Today with me, I have my partner Tamira. So Tamira, please join with me.
Yeah, Hasir, of course, I think that this session is very interesting and it's very helpful for the new innovators for this session. So without wasting much time, so I would like to invite the co-chairman this event, Niranjana Rashmi, to welcome you all. Niranjana, it's chance up to you.
Thank you so much, Hazira and Tamira. So, and hello everyone, and hope you all are staying safe despite the ongoing pandemic situation. As the co-chairman of InnovMind, I would like to warmly welcome you all to this occasion. And since there are some international participants here, I would like to say that if there were any issue with the time zone, first I want to apologize from all of you for that. Also, I would like to give my sincere gratitude for everyone who helped us to come this far to make this event a massive success. So InnovMind is an IoT workshop-based project which is organized by the IEEE Industry Application Society of Sri Lanka Technological Campus. We hope that this will be the best experience for all of you to learn about IoT to build up your career paths. First of all, I would like to warmly welcome our chief guest and the guest speaker of today, Mr. Thilinayapa Bandara, for attending here by dedicating your precious time. And also, I would like to warmly welcome the General Manager of Zone 24/7, Mr. Vipula Leonarachi, and the marketing team of Zone 24/7, who are the platinum sponsors of our project. Also, I would like to warmly welcome all
Recording
of
in progress.
advisors and the IEEE student branch advisors and all the IEEE executive committee members of IEEE student branch of Sri Lanka Technological Campus who join us today to make this event a success. Also, I warmly welcome you all who came today to participate in this valuable session, and also I hope this will be the best experience for all of you to learn about IoT to build up your career path. And I want to say that today's session is just the start and way more to go. We have 4 more workshop series to come in 19, 25, 26th of September, and also 3rd of October. And also there will be a competition to all of you. After you participate for all of our workshop series, you will be able to receive a valuable certificate, and also the winners of the competition will receive valuable certificates and cash prizes. So stay tuned with us. Stay tuned with IEEE Industry Application Society of Sri Lanka Technological Campus for more excitements. Thank you all. So enjoy the session. Take care and stay safe. Over to you, Hasira and Tamira.
Yes, thank you, Niranjana. So as Niranjana mentioned, further excitement will be further. So stay tuned with us. Stay tuned with InnovMind. So up next, we have a special advertisement from Zone 24/7. InnoMind is powered by Zone 24/7 and their support is immense to us, and especially it should be highly appreciated. So let's join hands with Mr. Vipula Lianarachi, the General Manager of Zone 24/7. Mr. Vipula, the virtual platform is over to you and the advertisement will be followed. Thank you. And yeah, before that, let me explain something more. I think you can use this pigeonhole platform in order to forward those questions during the session. So use this code to get into the platform. So you can use this website and please enter the passcode. And during the session, if you have any questions, you can forward those through this platform. So Mr. Vipula, please have your chance.
Right. Thank you very much. And thank you all for attending this session and welcome to InnovMind. So we being a company that has been always in the forefront of innovation, right? And a company where people talk about where robots walk and drones fly. So Zone 24 is excited to be part of this event. And I would like to thank the committee, organizing committee for allowing me to address this gathering. So innovation in the literal form is nothing new to, right? So that is actually what makes us different from all the other species. And again, it is nothing that is unique to engineering. Innovation is everywhere. So without taking a lot of time, I would like to allow you to go to the interesting part of this session, where my colleague Tilna will take you through a journey on IoT and allowing you to be participating in this innovation session. And thank you again, thanks all, and I wish you all the best, all the participants who's going to participate in this event. Thank you very much.
Our vision is to enhance the emotional experience of everyone we touch. Our mission is to weave software and hardware into best-in-class solutions that ensure the enduring growth of our clients. At Zone 24/7, we are committed to support our Fortune 1000 clientele, design the future in retail and high-tech industries. Our passion is fueling inspiration and enriching the lives of the people we meet throughout our journey, from our expertise in engineering.
We at Zone 24/7 provide the best of the breed technologies to our clients. Our DNA within our organization is to provide disruptive technologies which will change the way our clients perform and thereby making them highly successful. Most important, all these solutions we try to deliver on time and on budget. Our solutions come from throughout the world. We tend to bridge the relationships within Silicon Valley and the rest of the world, whereby we use our talent pool in Sri Lanka as well as our partner technology companies throughout the world.
Okay, thank you, Mr. Vipula Lianarachi, for the wonderful introductions and video. So I take this opportunity to introduce our guest speaker today. So he's bring over dedicated experience as a team player and a leader working in the information technology arena. Currently being a consultant in business solutions at Zone 24/7. And also he can experience in embedded system development, fast proof of concept designing and driving innovation within team. Further, his master's in business administration from the Postgraduate Institutes of Management, University of Jawaharlal, and bachelor's in engineering of the University of Morocco. So I would like to invite Mr. Tilena Yapa Bandara to continue this session. Sir, spotlight it on you.
How many of you believe that this time is one of the best times for you to invest into yourself and improve? And how many of you believe that this is not the best time to improve? Now, if you think of this dilemma of improving yourself during this pandemic, the so-called pandemic, while the entire world is sleeping and having fun, you took a decision that you're going to improve yourself. While you have a lot of other work, while you are busy at your other work, while you have lots of different types of other work, you took a decision that you, no matter what's going to happen, are going to take a firm and bold decision that you're going to be here, learn and improve yourself. While there's enough capability for you to just chill out on this Saturday. For that dedication, I'm going to say thank you very much for being here in this session. And with the power vested on me in this session for the next 1 hour or so, I'm going to make sure that I'm going to deliver 120% of the value and the energy that I can deliver to you, to make sure that you are at the elevated energy as well as you are improved version of where you are from now. My objective, my job is pretty simple in this forum. We are going to talk about Internet of Things, demystifying some of the things. And we are going to talk about general aspect of Internet of Things in a very generic steps, in a much more simpler step. How can you actually use that in different contexts? And I appreciate that we have international audience coming from and joining from different time frames. So good morning, good evening, and good afternoon to almost all of you. Thank you very much for being here. And thank you very much, especially because you took a bold decision to invest time to yourself. while half of the world is not doing so. And we are doing fantastic at the moment, and the world is doing absolutely great. And let's dig into this session. In this session, we are going to talk about Internet of Things, not just the theoretical aspect, but how to actually use that. What are the challenges that it brought and brings us, and how can we use that in different context? I can see that the audience comprises of not only engineering students, but also other aspects, other members of the audience context. It's a mix of audience. So I love this audience. Thank you very much, and let's dig this in. Now, the moment people start talking about Internet of Things, you get different pictures, don't you? Because the word Internet of Things, or IoT, which we will use interchangeably, has been used in many, many, many different contexts. You may have seen it, you may have heard about it, you may have heard different stories about that. You may have been introduced to the IoT fundamentals, the architecture. It may have appeared in different formats. Typically, when you heard Internet of Things, what you typically get is a beautiful picture like this with different icons. And sometimes definitely there will be a phone somewhere. There'll be an icon of Bluetooth, and there'll be icons of Wi-Fi. There'll be icons of cloud. There'll be items of internet. There'll be icons of connectivity, something, and it doesn't make sense most of the time. And to add to that, most of the time what happens is we typically hear this jargon related to Internet of Things, something like this. It brings us jargon where they talk about really difficult words where it sometimes doesn't even make sense. It typically contains words like identifiers, objects, network, human-to-human computing, edge computing, ubiquitous computing, jargon, filled with jargon. It brings much more complexity into the scenario. Now, I can see a lot of students, a lot of people, a lot of audience here. If this is the experience that you have so far experienced, I want all of you to raise your hand. I know there's a lot of students here, a lot of people. How many of you have been introduced to IoT in a much more complex way? A lot of pictures, a lot of jargon, a lot of words that you don't know. Here we go. Lots of people raising their hand. See, this is the reality. But in essence, ladies and gentlemen, thank you for that interactivity. I love this audience. I love this audience because this participation tells me that you are absolutely eager to be in this audience. So thank you for this wonderful interactivity. And don't forget the fact that we have a special platform so that you can ask questions, you can clarify your matters. This session, I would like this session to be an eye-opener for you. In fact, I'm not going to tell you that all your questions will be answered in this session. In fact, my premise is this. At the end of this session, you will have more questions. Huh? Does that even make sense? You may think this session is supposed to be clearing my questions, isn't it? But here's the deal. If I ask you whether you have any questions at the moment, most of the time, your mind will be blank at this moment. It's not clear, and it's not pretty focused, and we don't know what to ask. So my question, my objective in this session is to take you through a journey, and at the end, you will know exactly what questions to ask. And you will be doing that in a much more clearer sense. You will be clear about things to ask. You will be absolutely clear in your minds about Internet of Things, its usage, its research capability, and its applicability in different domains. Let it be engineering, let it be non-engineering, let it be general day-to-day life, or else let it be industrial applications, or even business aspects. That's what we are going to talk. That's what we are going to do in this session. So ladies and gentlemen, welcome to the new simplicity. We are going to talk about demystifying IoT, Internet of Things. And just because simplicity adds more beauty, more glamour to the occasion, we will be simplifying the situation. We will be simplifying the matters so that it is more generic sense. We don't need complex life, do we? The life is almost complex to most of us at the moment. So let's not try to make the life much more complex than this. Let's try to bring complexity into simplicity, because out of implicit complexities, typically simplicities arrive. That's why we thought of bringing more simplicity to the picture. Now, let's start talking about Internet of Things. Now, what's the best way to talk about Internet of Things? The best way I think to approach this question is to talk about internet. It's anyway Internet of Things. We should start talking about internet, isn't it? Well, is internet good or is it internet bad? If I ask that question from a different audience, I can remember 1 week ago, I had a different training program where the majority were, uh, our older generation, probably people who were over 50 years old. I asked the same question: is internet good or is internet bad? You won't believe that the majority of the answers that I received on the negative connotation, that internet was bad. Internet was bad. It's giving all the bad things. But I understand that this audience is much more positive. And if I ask the question, I'm 110% sure that you all will agree that internet is good. But I think that internet is neither good nor bad, but it's a tool that we can use. So we'll use that connotation in this session. Internet is just a tool for us to use. Internet is a wonderful tool. It's a beautiful thing that has come to us, isn't it? The mobile phones, the cameras, the laptops that we are working now, everything has become much more smarter because of the introduction of the internet. Think about it. We can listen to any song that we like. We can watch any movie that we like. We can play any game that we like. We can do anything in the world right now just with your mobile phone. So the mobile phone has become much more smarter with the introduction of internet. Now, I want you to think about a little bit, few years back, probably you were not born, some of you. When I was young, I can remember the old mobile devices. People will vouch for this, and some of other members in the audience will vouch for this. The previous history, the history where mobile phones were not so smart. We had this Gadolbaga phone, if you call it. In Sinhalese, we call it Gadolbaga, where the things were not that smart. We could just call someone, or we could have just send text messages to someone. That's it. That's what it could do. But nowadays, the times are changed. With the advent of internet, we are thinking about doing anything and everything using your mobile phone. Sometimes you won't even need your company laptop to do your work, because your mobile phone is just enough for you to do almost all the work that you can do under the world. And connecting one person to another person, connecting one person to other available material is what this internet has done. If you want to download a song, you may not have that song on your device, but you know some place where the song is, YouTube. You know places where images are, Google. You know places where movies are, Netflix, Spotify, all these places, you know where to get these things. So internet has made possible to connect things. This is where Internet of Things comes into the picture. In simplest forms, we are talking about taking all the physical places and things in the world. We are talking about connecting all of them together to internet. So earliest, we were talking about connecting people. I will be connected to you. But now we are talking about connecting things to internet. Imagine connecting your chair that you are sitting to internet. Imagine connecting your car, your house, your dog, your anything to internet. How cool that would be. So no more we are talking about a world where people are connected to each other, but we are talking about the next level of connection, which is connecting anything and everything to the internet. So simplest form, we are talking about connecting anything physical to internet. That is what Internet of Things mean. But why should we do that? Why question is an important question, isn't it? When you have three questions, when you have the why factor, the how factor, and the what factor, the most important factor is why factor. Without knowing why we are doing this, there's no value in doing this. Why should you do that? Why should you connect all things outside to internet? Why should you start connecting your chair to internet? Is there a value? Why should you connect your car to the internet? Why should you connect your refrigerator to internet? Why should you connect your washing machine to internet? Why should you connect your buildings to the internet? Is there any real value? Is there any importance of doing that? Why? This is the exact question that we should ask. And this is exactly the question that we don't remember to ask. We typically get bombarded with the what factor and how to do IoT, but we typically forget to ask why are we doing this. In fact, before we even start talking about the why factor, let's see a common word that we typically misuse, especially in Sri Lanka. And mostly like in the many parts of the world, the word smart is typically misused. You get people talking about everything being smart, but everything can't be smart. We call people smart people. Whenever we have a solution, we call that a smart solution. I have seen many students giving their final year project proposal and call it smart project. What's the criteria of making something smart? If you need a solution which is a smart solution, what's the minimum criteria? What's the criteria for making something smart? There is a criteria to make something smart. Let's see in very quick essence, what's the criteria to make something smart? In essence, we are talking about three things. Number one is that smartness means you need to have the capability to sense. You need to have the capability to sense. Here is sensing. And number two, sensing is not enough. I mean, we as human beings, we can sense. We have our eyes, we have our nose, we have our skin, sensing capability. Likewise, the devices also need to have the sensing capability. This is not enough, but then we need to have the ability to actuate. Actuate means do something. Think about us. We have limbs, we have muscles, we have our entire body that we can do something. We can activate our muscles, do something. I can punch you. I can touch you. Actuation. Actuation is typically given to us by the processing systems, which is typically governed through sensing. So sensing leads to actuation. Is that enough? If you have a system that you can do sensing and actuation, do you call it a smart system? Typically, no. You are missing one more point, which we typically call, what's that? What's that? This is really important. Controlling. You need to have the ability to control things. Just because you can sense and actuate, you can call it smart, but you need to be able to control the situation. Based on how the output is changing, can you change your input things? Can you change the things as the output is changing? Can you change actuation based on the feedback that you are getting? So you have sensing mechanisms, you have actuation mechanism, you have control mechanisms, but is this enough? If you have these 3 points, can you call it a smart system? I don't still think so. Why? It's because we have data coming into the system. There's one little piece that's missing in the entire ecosystem, and that's the critical section. The most critical system section in any smart system is this. What's that? It's the capability to take decisions. It's the capability to take decisions. On what? On the available data. If your system can analyze, process the available data, and take decisions based on the available data, based on the available adaptive data, if you can take decisions, there you are calling a smart system. So just sensing is not going to do the job, just actuation and controlling is not going to do the job, but a system which have sensing, actuation, control, and which can act upon the existing data, available data, and take informed decisions is what we call a smart system. Now let's think about us. If you go to Facebook early in the morning, which you are not supposed to do, if you get up early in the morning and go to Facebook, what do you see typically in Facebook? You get people talking about problems. You get people talking about problems, analyzing problems, but not giving solutions. That's the majority of the people that you see in Facebook, don't you? You get people who talks about problems, who analyze the problems, but no solutions. Do you call it smart? You can't call it smart because you're missing something. You're missing the points of taking decisions based on that. So you can't tell yourself smart thing, ladies and gentlemen, because you are the cream, you are the next generation of this country. Analyzing the questions, analyzing the problems is just one part of the equation. But the other part of the equation is giving solutions. So unless you can act upon the problems and do something about the problem, you're not smart. If you want to really be smart, take this from us. You need to analyze the problem, and also you need to bring a solution to that. Then we'll call you smart. So if your project is going to be a smart project, if your IoT device is going to be a smart device, you got to have sensing, you got to have actuation, controlling, and also the ability to take informed decisions and act upon those decisions. That's what makes a smart device. Now we have talked about smartness. What's the link between smart and what we call IoT? What's the link between these two? Why are we still talking about Internet of Things? Why does it matter to do, connect everything into internet? Let's have a little discussion on that. Now, the first thing is, see, when you get to talk about IoT, you are going to talk about three things there. First and foremost, you have certain things in the physical world which can collect information and send it to someplace. So think of anything that's in the world, it falls into three sections. Number one is things that can collect information and send it. Typically, you know that in technical terms, we call it what? In technical terms, we call it sensors, right? This is not just technical. This is not jargon. Everybody knows this. Every one of us use this. We call it sensors. Sensors is pretty simple. You sense the environment. You see what's going on in the environment. So it's what we call sensors. You have typical many number of sensors now. If you want to sense the environment, you have many types of sensors available at the moment. You want to measure temperature, there's a sensor. You want to measure light level, there's a sensor. You want to measure pressure, there's a sensor. You want to measure gas level, there's a sensor. You want to measure whatever the thing that you like, there's a sensor. Sensors to sense the system, just like us human beings, we can sense the environment. See, we have eyes, we have ears, we have nose, we have everything that we can sense the environment. You are human beings, you can sense the environment. That's just one part of the equation. Again, that's just one part of the equation. So we have things which can sense. Let's take an example. See, one of the famous examples of Internet of Things is giving ability and Internet of Things or capability much more smartness to the field of agriculture. How do you make agriculture field much more smart? This is typically a common example that everyone talks about in IoT. So let's start about talking about that itself here, because it'll be easier for all of us to grasp. And we understand that there are different audience members here, but we all understand this section. By the way, we have over exactly 1,000 participants. Thank you very much for being here. And I understand there are a lot of people connecting through Facebook Live, YouTube Live. You are all within this forum. I can feel you. I can sense you. Thank you very much for being here. So let's stick into this. We have sensors which can collect information, send it. Let's put some sensors onto a paddy field, onto the agriculture. We can sense the soil level. We can sense the water level, the need for water. We can sense the need for the fertilizer. We can sense how much humidity is there. We can sense how much light is there. We can sense anything and everything in agriculture form. And a farmer can take informed decisions based on that. Farmer can take informed decisions. Now, my father still, going to paddy fields, even after doing his work, he loves to go to the paddy field just to check how things are. But we are now talking about putting some sensors into the paddy field, getting this information back home, where I won't even need to go to the paddy field just to see how things are going. This might be a bit hypothetical situation, but this is one such example that we are talking about. And this is not just the only thing. Let's talk about the second type of the things that can happen. What's the second type of the thing that can happen? That is obviously things that can receive information and then act upon that. What's that? Things that can receive on top of the thing and then act upon that. Receive information and then act upon this. What type of things? All right, here you have a printer. See, you have a printer here, which is a typical example of a device which receives information and print something. So you receive information and print something which is acting upon it. So there are sensors and there are devices which we typically call actuators. These are devices which we call actuators. Actuators, right? Actuators are things which can receive information and then act upon it, like a printer. Printers get information and print data, actuate on that. And what's the next thing? Then we have third one, which brings the best of the power to the world of IoT. Those are the things that can do both. That can do both. Now, let's think about that paddy field example again, the agriculture example again. Now we are talking about sensors which can identify the water level, that can identify the humidity, and based on that information, act upon that. Probably you can control the irrigation system, right? No more we need to send information to the farmer. So the farmer doesn't need to rush to the paddy field to take, do something. Instead, we are talking about the devices itself taking informed decisions based on the available data. So you sense that the water level is not enough. Control the irrigation system, turn on the water, let there be water. You understand that the fertilization is not enough. You take an informed decision and turn on the system to send fertilization. We are talking about things, devices which can do both. What are the both things? Number one is collecting information. Number two is acting upon the information. So we are talking about both things. And you can even go one step further, right? You can have sensors which connect to internet, right? Internet. Here is sensors connecting to internet. And probably, let's say, the sensors itself can listen to the weather forecast from the Weather Forecast Bureau or someplace. And based on the weather forecast, let's say the weather forecast says there's a possibility, high possibility that there's a rain today. If there's a high possibility of raining, probably it can take a decision, right? Here's a decision that they are not going to turn on the irrigation system if the water is not enough because it's going to rain. That's the next level. You are not taking just based on the data that's available, but you are even able to take some informed decision based on some probable data, predict data, predict the future and take decisions. This is the next level that we are talking about as Internet of Things. Now, this is just one part of the equation. Let's move to the next part of the equation. The next part of the equation is the power of IoT. If you think of the power of IoT, the power of IoT resides in many factors, in many layers. Now, I understand that this large audience that we have here today comprises of different industries, different businesses, different fields of study, students joining with us from different faculties. So you may come from different places, different jurisdictions, different fields. Is IoT going to help your field? There's a high chance that it's going to help your field. It can help many fields to become much more smarter. There's a high chance that it can help almost all fields. Let's take a few examples. Think about the asset tracking example. Here we have asset tracking, right? The second one, asset tracking. If you think of asset tracking, do you think that asset tracking is going to help you to take informed decisions? Absolutely, yes. Asset tracking. Let's think of a situation where you are doing asset tracking. Let's think of a hospital. These days, everyone talks about hospitals. So let's also talk about hospitals. In a typical hospital platform, so let's say there's a critical patient, and you need to do something about this patient. And the doctor says, bring the mobile X-ray machine. The doctor instruct the nurses to bring the X-ray machine as quick as possible. Now, what's the typical thing a nurses do? Nurse doesn't know where the X-ray machine is. The portable X-ray machine, you know, there are portable X-ray machines that you can push things. I'm just making up this, by the way. So if the doctor says, bring the X-ray machine quickly, nurses have to go and find, where's the X-ray machine? Where's the machine? Where's the X-ray machine? Did you see the X-ray machine? Is it with you? Is it in your system? You just take a call. Hi, is the X-ray machine in your system? No. Is the X-ray machine in your flow? Everybody rushes to find the X-ray machine. This is typically what finds. This may happen in your system also. This may happen in your offices also. People are trying to find where the things are. And by the time X-ray machine comes, probably a few minutes are gone. And by the way, did you know, interestingly, according to research, nurses all around the world spend 1 hour, right? Listen to me very carefully. This is very important. Nurses all around the world spends 1 hour during their shift to check for devices and instruments, to search for things. Can you think about it? Can you imagine it? During the critical, the time that nurses are supposed to, I mean, they are giving their service, they are spending 1 hour searching for things. Nurses are doing absolutely brilliant work. What if we can reduce that 1 hour into 10 minutes? It's going to add a lot of value. It's going to save a lot of lives. That's exactly what smart devices or IoT can do. You are just able to track any device if you have IoT systems within the thing. Now, although although that claim seems or sounds much more appealing and much more sounds and much more fun to have, it's not that simple. I understand that there are inherent challenges and problems that comes with that, but that's where engineers come into the play. If you are an engineer, by the way, these are the actual questions, challenges that you may be forced with, that you may be entrusted with. Those are the actual problems that you may need to solve. Asset tracking is one such good example. Think about manufacturing efficiency. What about maintaining machines? Think about manufacturing efficiency. What about maintaining of machines? If you want to maintain machines, right, like this, manufacturing of efficiency, if you want to maintain machines, it's not a easy thing, right? If you have a fleet of machines, you need to go to each machine, check if the oil levels are good, check if the wear and tear is okay, and check if the maintenance period has come. You have to manually check, manually go to each machine and see if things are good. And this is time consuming. This is time consuming. And think about this. If I am a person who is expert in maintaining machine, when I need to walk from one machine to another machine to another machine to another machine, my time is spent not to maintain machines, but to walk to machines. Just like nurses, I'm spending 50% of my time not maintaining machines, but walking from machine to machine. What if I can be much more productive? Because listen to me, ladies and gentlemen, you are the next level of this generation. Next generation is all about productivity. Unless you improve on your productivity, you're going to be thrown out. That's said, and that is it. Unless you are a better productive person, you will be absolutely very clearly there's a high chance that you will be overthrown or you will be superseded by someone else. Because the next generation is all about productivity. Productivity is essential. Daily maintaining your productivity at a higher level, maintaining your productivity at a higher level is absolutely a necessity. So if you're an expert machine maintainer, productivity comes when you are actually doing what you are expert about. Can you do something about this? Can we make machines talk to you, right? Instead of you talking and going there and checking if the machines are working, can you have a system where here is a machine start talking to you instead of you talking to machine? Here is you waiting, right? Waiting and looking your Facebook in the company laptop, and the machine start talking to you and say, hey, mister, stop what you are doing. My oil level is not enough. Come and fill me. I have to stop my Facebook, go to the machine, fill the tank, and come back. What if machines can talk to you and say, my wear and tear is too much. My maintenance time period is coming. Now it's time to maintain me. It's time to lubricate me. What if machines can talk to you? It's absolutely going to improve your things. It's not going to take away jobs. It's going to repurpose jobs. So the maintenance guy is not going to lose the job, but instead his life will be much more productive because of IoT. That's what it can do. And as usual, I mean, if you are related to anything of health and safety, think about disaster warning. Disaster warning is absolutely important, isn't it? If there's a tsunami coming in, if there is a flood coming in, what if there's a pre-warning system? I mean, this is typically evident now. Most of the countries are now talking about pre-disaster evaluation systems, but you don't see much of the things in real application, do you? Why is that? That's because that's supposed to be created and done by your generation. The knowledge is there, and we will together create these systems. The challenges are there, but together we can solve those challenges. We can create these kind of IoT things absolutely with ASIP. Even if you're coming from law enforcement, I can remember one example, one project that Zone 24/7 we received was regarding law enforcement. I think it was related to Philippines or a regional country, where the expectation was to do surveillance, and based on the surveillance to predict the possibility of people taking part in illegal activities while they are in the road. We had to consider decisions, take decisions based on the video surveillance. That is basically coming from law enforcement. Can you surveillance people and predict if there's going to be crimes? Can you predict if there's going to be riots even before the riots are going? I can still remember one solution that we had. It was evident in our promotional video. We had a production system called CWAP. It was a video surveillance system, and it was capable of identifying burglary even before people come and try to, break a store. Just few seconds before, we could identify that it's a possible burglary and inform the police. And it was really evident, it was really highly regarded, and that in fact stopped one burglary activity, and that was absolutely brilliant. So these kind of things are now actually slowly coming into the market. So what I want to say is, you may be from different industries. You may necessarily not be in the engineering industry, but whatever the industry you are, this is still valid for you. So law enforcement, it's really evident. Let's take one final thing. What about caregiving? I can still remember finally a project that I did with one of a pretty great student. It was related to identifying possible falling of an elder person. It was a wearable band that the elders can wear when there's a possibility of the elders falling down. The system will identify the necessary people about that. Now, it's theoretically great, but when practically implementing, you get a lot of challenges. But these challenges are things that you can really do something about that. But the value that it can bring to the world is enormous, as you can understand. So these are some of the powers that IoT is able to bring to you. And absolutely, one thing which is very evident is, if you forget everything here in this list, everything that we have talked so fast, one thing which is very clear is that one thing which is very evident from this list is, if you forget everything else, but this is all about nothing else but all about better experience. This is all about just better experience. So Internet of Things is in essence all about better experience. I'll remind you that if you have any questions, we have a forum that we can talk about questions. Put any questions there. We'll be taking few minutes at the end of this presentation to talk about your questions as well. I'm now seeing and I'm now feeling that you may be getting much more clarity related to this. Now, how does the actual IoT system really works? This is a typical question that we get. How does the actual IoT system typically work? Now, when you talk about IoT system that typically works, there are few things that you need to talk about, that you need to know about. First and foremost, you are talking about devices, right? Things like sensors and actuators. Then you obviously have to talk about connectivity. There should be internet connectivity. There should be other types of connectivity. There should be wireless connectivity. There'll be many other sorts of connectivity. And obviously, there should be a capability to do data processing. This can be a small processing capability. This can be a very powerful computing capability. The processing can happen on a mobile phone. The processing can happen on a super fast GPU-based computer. Processing can happen on a supercomputer, processing can happen on a very tiny computer like Arduino. If you are aware of things like Arduino, processing is critical, whatever the situation is. And finally, we have a very important section which is called user interface. How do you link all the decisions, all the analysis, all the reporting that comes out of the systems to human readable manner? When you have these four things, when you fuse all these four things together, you got IoT. You got something that can serve the mankind, that can make user experience much more doable, much more absorbable. You have sensors, or you have devices, you have connectivity, you have data processing to process something, and you have user interfaces which can evidently give reports, readable information, analysis to the users. These are four simple things. Well, easier said than done, isn't it? Let's take an example and see how this is really done. Just to give you an understanding of a real IoT system, since we talked about agricultural system, in fact, let's talk about IoT through agricultural example. Now, I come from a rural village. I come from Mavanella, if you know it. It's in kind of the central part of the Sri Lanka. And if you remember, when you are coming from Kandy down to Colombo, when you are passing Kadugannav region, you get a scenery view of long distance scenery. It's one of the most beautiful places in Sri Lanka. If you are not from Sri Lanka, you must visit Sri Lanka, and Kadugannav is one place where it's breathtaking. Yeah, you get a view of vast paddy fields which will catch your breath, and it's absolutely magnificent. Now, I live in a place, my village is from a place where at the bottom of that base, where the paddy fields are. So if you look at this picture carefully, this is the paddy fields that you see when you are looking from Kadugannava. In fact, let me show you where Kadugannava is. You see this mountain here, the simple mountain range here. This is that Kadugannava region that you typically see. Typically, when the trains are going, we can typically see the trains going there. So that's the Kadugannava mountain, and the paddy fields that you see from there are the paddy fields in the region of our villages. So here's a paddy field to you. How can you make it much more smarter? How can you make this paddy field supported by IoT? Let's think about that a little bit moment. Now, some of the things that we are going to talk here are going to be fictional. Still, it's going to be fictional. You may feel that, oh, this is not practical to do that. You may feel, oh, it's easier said than done. You may say, oh, these are not practical things. These are just made up things. Well, a few years back, if you talk about talking to your mother and father through a mobile phone, few years back would be magic. People will say, you can't do that. If you start saying that you can send movies from your mobile phone to someone else, earlier, few years back, I would have even laughed at you. So some of the things that we are going to talk right here, you will laugh, because some of the things looks like that they are magic or not doable or not practical. But mind you, times are changing. What's magic today might not be magic tomorrow. Things are changing. The technology era is changing. Engineers are working hard every day, and the world is getting a better place to live because of the increased use of technology. So things might happen tomorrow. So if you get a slightest feeling that these are impractical things, be with that idea, because tomorrow the ideas will be real. So let's think about how can you make these paddy fields much more smarter? How can you apply the concepts of IoT to this paddy field, to the paddy fields in my village? What I would prefer is to first look at this paddy field and to get the capability of learning about the current status, or to learn about current environmental conditions of the paddy field from my home itself. What can you do about that? Well, let's think about that. One thing that I can do is I can install some sensors into this paddy field. So here are a few sensors. I am just making few sensors. Here are some soil moisture sensors. You can measure how much water is there. Right here, I have placed few sensors onto the paddy field. Then you need to measure the fertilizer level. You need to measure the water level. There are a lot of paddy fields, by the way. You have to make space for a lot of sensors. See, all these white circles are going to be sensors. So here are sensors everywhere, everywhere in the paddy fields. Wherever there's a paddy field, I'm going to make it smarter. Apply Internet of Things sensors. Here are sensors everywhere, everywhere. There are paddy field. I'm going to put soil moisture sensors, water level sensors, humidity sensors, temperature sensors, light level sensors. You can see the paddy field becomes a field of sensors. It's everywhere. Now it's all good. Sensors, what are they supposed to do? Sensors are supposed to sense the environment. It's supposed to take information and send back to us. Now, let's talk about the first section of IoT. Remember, the first section of IoT was about sensors and devices. When talking about sensors and devices, especially these sensors that we are talking about at this moment, there are two things that you need to worry about. In fact, that you are challenged about. What are those two things? First and foremost, you need to consider so seriously about the power consumption of these sensors. How are you going to power these devices? I mean, you're talking about the middle of nowhere where there's no electricity line. Do you see any electricity lines going here? No, this is just paddy fields. In fact, my house is about 500 meters away from this. So nearby, you don't find any electricity. So you can't plug wires, unfortunately. So how do you find power to these sensors? Because all sensors need some sort of a power line, some sort of a power mechanism. So are you going to plug batteries to these things? Well, it's a vast number of sensors. Okay, let's talk about sensor power through batteries. How many sensors? Hundreds of them? Are you okay to buy 200 batteries? Well, seems okay. All right, let's decide that you are going to use batteries for all the sensors. Probably those batteries are supposed to work many years without changing. That's what we call, engineers, you know this, that's what we call low power designs, low power designs. You make sensors that can work with single batteries many more years, like 4 years, 5 years. I can remember one IoT device that we made in Zone 24/7 was a smart display which could work with 2 pentorch batteries, 2 AA batteries for 4 years. It was a device that can work with RF and can change the content when needed, and it could work with 2 AA batteries for 4 years. And that's what we are talking about, low power design. So let's take a decision that we are going to apply batteries to these sensors. Is it the only way that you can power? No, probably you can apply something. We have sunlight, enough sunlight here. So probably you might take decision, let's make something that you can gather sunlight, maybe some sort of solar panel, something like that. Or maybe wind generated power, something or the other. That's one problem. The other challenge is, how do you upgrade firmware? But firmware can be a new word for you. Firmware just lies between software and hardware. So you know that there's something called software. So in a typical system, you have software. Here's software. And typically you have hardware, right? Hardware. You take the software layer and the hardware layer. Sometimes we have a little bit of system software which sits in between software and hardware. Typical example is in your computers that you use typically day by day, you have your hardware like motherboard, RAM, ROM, hardware, GPU, these are hardware. Then you have software, your operating system, your Microsoft, your movie makers, your all things are software. Now, in between your operating system and your hardware, you have another section called drivers. That's firmware. And you come to these small, tiny sensors, you still have firmware. If you want to change these firmware, how can you do that? I mean, it's nearly impossible, isn't it? Change the firmware of these sensors, nearly impossible. You are talking about hundreds of sensors. Can you go to each sensor, put a USB wire and upgrade the software? Nearly impossible. So you got to have a mechanism to do that. Typically in IoT, you call it OTA, over the air updates. You got to do that wirelessly somehow without even touching the system. Can you change the software inside the system using over the air updates, OTA updates? This is the challenge. So when you have a typical IoT platform, selecting of the devices or selecting of the hardware is going to be depending on these two things. What are the two things? Number one, power need. And second, how do you upgrade their firmware, OTA. These we are talking about the hardware, the lowest level hardware devices. These are the typical challenges. And in fact, there can be other things like, let's say, there's a base station where, right, let's imagine in the middle of the paddy field, there's a base station which wirelessly talks to all sensors, right? Let's say here also you have a base station where wirelessly it talks to all sensors and get information and do act upon that information. These base stations will also need power. Probably you can put up a solar panel here, right? Then base station has power. And probably there can be a small tiny battery that goes with all sensors. There you go. You know, these are interesting concepts. These are interesting concepts. Seems like possible. In fact, I can remember one IoT system that was really ingenious. When I can't remember exactly which country was that. One country was implementing a bridge, and during the implementation phase of this bridge, it was a bridge that was like an arc. Remember, you have bridges that are like arcs. You know, making that bridge, what engineers did was, while they were mixing cement for the bridge, they put sensors into the concrete mixture and made the bridge. Now, after the bridge is made, now the bridge is communicating to us and telling information about the bridge. It's saying how much pressure is it getting, because the sensors are mixed with concrete. It can tell you how much stress is it getting every day, how much pressure is it getting every day, how much vehicles are going on that every day. Is it going to last for next 25 years? It can tell you. See, we are talking about machines and things, analyzing things, taking decisions based on the available data. That's what we're talking about, the next generation. So next level of bridges are not going to be just bridges, but they are going to be smart bridges. Some of you might laugh for these things. Some of you might think these are just fictional things, dreams, but dreams become reality if you put enough sweat into that. Ladies and gentlemen, if you put enough sweat into that, dreams can become reality. In fact, one of my best quotes is, dreams are not those things that you see when you are sleeping, but dreams are those things that will never ever let you sleep. If you are a dreamer, you become an achiever, because in the evening, in the night, if you have a real dream, it won't let you sleep. You see, I get a feeling about dreams like this. If you don't have a dream in your life, that's your first problem, ladies and gentlemen. If you don't have a dream, that's your first problem. Your second problem is if your dreams are not big enough. So if you don't have a dream, you're going to have a dream. If you have a dream, ask from yourself, is that dream big enough? If the dream is not scaring you at night, if that dream is not making you difficult to breathe, that dream is not enough for you. Your dreams need to be big. If you don't have that kind of a dream, that's your second problem. Have a dream, and that dream needs to be big. So we are talking about some magic here for some of us, but that dreams becomes reality. These magics will happen, and it has started happening all throughout the world. Now, this paddy field looks great now. You have sensors, you are getting information, you are acting upon that, you are taking decisions on this. Brilliant. Now, you have done this project. My village seems brilliant. The news spreads to the next village, to the next village, to the next village. And everybody says, wow, this guy has made this paddy field smarter. Now there's IoT in this paddy field. Every news goes in the news, local news, right? Everybody is now talking about the smart IoT enabled paddy field. Suddenly, someone invites you to do another project. This time, a bigger paddy field. And you look at that and you took a deep breath. Earlier, you had just few acres of paddy field. And now, oh my goodness, look at this. It's a vast area of paddy fields. How can you put sensors in almost all these paddy fields? Now, are you going to put batteries? Or are you going to put just one or two base stations to send signals from here to there? You are going to have such a nightmare to put paddy fields, to put things into this area. It's going to be a nightmare. It's going to be a challenge. but it's a challenge. Engineers know challenges are what keeps us from living. We love challenges, don't you? All engineering students, you love challenges, don't you? Raise your hands if you agree with me, if you're an engineering student, and if you agree that challenges are what keeps you living. I want you to raise your hands. You may be looking at this on YouTube or Facebook. If challenges are keeping you alive, you are very much active. I want you to put a thumbs up to yourself and give a pat on the back to yourself and give a round of applause to yourself, because if challenges are keeping you alive, you are real. You're a human being. That's what we need in this country, in this world. You are the crux of the material. And now here's a challenge to you. You have a vast area. And let's imagine somehow you found a solution, and now you're moving to the next level. Here's the next level. You're given an entire district. Here I have been given the Anuradhapura district, entire Anuradhapura district. How can you apply smart agriculture to the entire Anuradhapura district? If you don't know what Anuradhapura is, if you're not from Sri Lanka, Anuradhapura is one of the largest cities in Sri Lanka, and which is vastly being taken by agriculture. There are a lot of beautiful places, much history, a brilliant place to visit, as well as a lot of paddy fields, a lot of water, and a lot of dry seasons, a lot of mixed culture, but a lot of paddy fields, a lot of agriculture. What if you are equipped with the concept of giving Internet of Things, smarter paddy fields, smarter agriculture in the entire vicinity of Anuradhapura? So you can see the goosebumps that you are getting probably. That's because we are talking about a major issue here, major challenge here. What's the challenge? It's all about scaling and operations. This is typically something people forget. This is typically something people forget, because it's not simple to do a scaled operation. Operations and scaling is not just simple. It's not just all of a sudden you will find that things are much more serious. It's not that easy. When you are talking about scaling, you may be able to do a simple demonstration that IoT system works. You may be able to show that a simple POC, a proof of concept, that things work. See, I'm talking about some of the jargon here. Let me explain some of these jargons. By the way, thank you very much for your interactivity. I can see most of you interacting with me and giving me answers. I love this audience. Fantastic for doing that. And see, the most important word, the word that I love is POC. POC, see, POC, proof of concepts. It's easy to do POC. It's easy to do a demonstration, but the life becomes absolutely severe and much more, typically not that simple when you talk about the reality of the situation, or when you talk about the scaling and operation of a POC. So we can do POCs, we can do demonstrations, but we are talking about the actual implementations, You have other problems. I get a lot of people, I got a lot of students who keep on talking about POCs, who keep on presenting their final year projects, where they come up with brilliant ideas, but they are good in POC, they are good in demonstrations, but most of them, almost all of them, fail when we start thinking about scaling. Now, here's a challenge to you. Now, you may not be an engineering student. You may not be an engineering student. You may be an engineering student. But no matter where you are, no matter where you are coming from, you may be engineering or not may be engineering. Still, here's a problem to you. Whenever you are thinking about problem, I need you to do two things. Number one, when you got a problem, I need you to do, number one, find an answer to that. Because thinking about problem is itself not going to be enough. We have enough people in this world talking about problems. So here's a challenge to you. Instead of talking about problems, be that person, be that change who talks about the answers to the problems, not about the question itself, but talks about the answers to the question. But this is not enough. This answer, when you're talking about the answer, you may be thinking about a dream or a POC level answer. You may be talking about a POC, proof of concept level answer. You may be thinking about a demo level answer, right? But think about the next level of the answer. Can you scale that answer? Can you make sure that the operations are valid for that answer? See, these are POC times, and people are giving solutions to their problems. See, I can see people talking in Facebook how they can revolutionize the politics, how they can revolutionize the current COVID problems, how they can revolutionize the medical problems. But most of the times, they are talking about POC levels, proof of concepts. They're talking about demo applications. They have not even considered the scaling problems. They have not even considered the operation problems. What are the operation problems? What are the scaling problems? Related to IoT, here are a few problems. See, look at this. Not problems per se, but they're challenges. You need to think about more power considerations. Right? If you're scaling about putting sensors to the entire Anuradhapura district, you may be not even think about putting batteries anymore. Or even if you are putting batteries, you can't visit all the sensors and think about changing batteries. Number one, how much batteries? How many batteries you are talking about? And you can't even plug batteries there. You don't know where the sensors are. Imagine there's a GPS sensor. If the battery depletes, you might even not know where the sensor is because there's no GPS sensitivity when the battery goes away. This is a fantastic thing to discuss about. So think about scaling. When it comes to scaling, you need to think about more power consideration. That's where things like wireless power comes into the play. See, now the technologies are there where you can wirelessly charge things. You may need a mesh that you can wirelessly charge, or you may need consider solar powered things, wind powered things, pressure powered things. You may need to consider about wirelessly charging things without even visiting these things. You may think about bins where you can put the sensors and where the sensors will be powered again in few seconds. You may be considered about even throwing away sensors if these things are cheap enough and putting new sensors when the power goes out. Did you consider those things when you think about scaling and operation? This is one thing to consider. And the second thing to consider is about the devices association. Have you associated sensors to devices? Let's say you have 100,000 devices. Do you know which sensor is in which field? Do you know which motor is in which district? Do you know which field has sensors and doesn't have sensors? Association of these sensors to actual things is a challenge. That's the second challenge. Third most important challenge is errors. Now we can think about a perfect IoT solution in the discussions, but in reality, you know, when you talk about real operation, real engineering, most of the work, most of the effort is typically gone into debugging of things. We call it in engineering, you call it debugging. Debugging means when you find that something is wrong, how do you find where is wrong? What's gone wrong? That's called debugging. Majority of the time is generally spent for debugging or testing. Testing is important, isn't it? You got to find a lot of time for testing and debugging where things are going wrong, which means apparently when it comes to IoT or any place where there's software and hardware, there's going to be errors. There's going to be a lot of errors. There are going to be a lot of bugs. There's going to be a lot of issues. There's going to be a lot of testing involved, which means the third challenge is about finding the issues as and when it appears. If there's a problem in a certain sensor, let's say there's a GPS sensor finding and connecting to satellites and giving location information. If there's a problem in that sensor, you might not know even where the sensor is. You might have to think about that before you even think about doing the project. Those are scaling problems. So here are three very simple scaling problems, challenges. Why did I talk about these challenges? The challenge, the reason why I talked about these challenges is not to, put you down saying that IoT is a difficult thing to do. But the whole point is to open your eyes. When you are thinking of solutions, remember we are talking about solving problems. When you are thinking about solving problems, think of these vast problems, scaling problems, operational problems, these challenges. These challenges are challenges that you need to think about. It's not only the tip of the iceberg example. When you get an iceberg, here's an iceberg, right? Tip of the problem. And in the bottom of the thing, you get a lot of bigger problems. These bigger problems, the bigger challenges are typically not seen by typical people. Majority of the people, especially in Facebook, they only see the top of the problem and start talking about the tip of the iceberg, where there are bigger problems hidden beneath. Your job as the next generation, as the ingenious generation, is to look at the bottom of the problem. Look at these bigger problems, bigger challenges, and think how can you solve these problems, these challenges. So if you, I want to challenge you here, ladies and gentlemen. If you're a student, if you're an undergraduate, I want to challenge you. Here's my challenge. If you are designing your IoT product or your final year project, I want you to consider about scaling and operability, scaling and operation level challenges right when you are designing a system. Don't just think about POC level and doing something for the sake of doing, but think of scaling, think of operations. If you can do it, I can guarantee that you will be the next level leader. You will be the next level Steve Jobs. Nobody will be able to stop that happening. That's about scaling and operation. Now, to just give you a overall picture of what IoT looks like, it's pretty simple, right? It's pretty simple. You have devices now which has capability to connect to internet, and you give that capability through sensors, through other devices, through other hardware, and there will be different sensors, different actuators involved here. So you have sensoring here, right? You have sensors here, and also you have actuators here. Typically, this is where you get hardware. HW stands for hardware. Typically, this is where you have hardware involved. That's the first layer. And this first layer is going to typically talk to what we call a gateway. A gateway. A gateway is the actual device that typically gets connected to internet. In Internet of Things or Internet of Things, IoT, we don't typically see the end devices directly connecting to IoT. Why? Obviously, you may understand that's because of the power reasons. Connecting to internet, connecting to your wireless, connecting to your Wi-Fi is going to enormously take power. So if you start connecting all the hardware into internet, it's going to be a tedious task. It's going to take enormous power problems. So power becomes a bigger problem. It will be difficult to connect all hardware into internet because of inherent power problems. Or it can be a difficult problem, something like varying protocols. Varying protocols. What are protocols? Protocols means what's the method that you are talking one person to next person. See here, we are talking in a protocol. I'm talking in English. You understand English. English to English. I talk in English. You understand English. Our protocol is talking, voice over English. We understand. And if I start talking in another language like Chinese, unless you understand Chinese, the protocol will not be understood. The problem with hardware is different types of hardware have their own protocols, which might not be common. So different protocols are going to challenge internet. So it's difficult to manage with all these sort of different types of protocols. That's a difficulty. What if we can amend all protocols into one and bring more clarity? Just one thing. Probably if you are into IoT, you may have of things like MQTT, right? You may have heard of things like MQTT. These are what I call as generic protocols, where you can bring all the sort of edge protocols and make it much more generic. And one other thing will be unfiltered data. Sensors might be sending unintentional data that you don't typically need. Or there may be security issues, or there can be latency issues. Latency, it can be a problem. Latency means how long does it take for your system to receive information. Latencies can be pretty long. If you have an internet connection through Wi-Fi, latency can be a problem. How fast can you get data? If you have an internet connection through GSM, through cellular connections, it can be pretty slow, by the way. Can be pretty slow, so latency is a problem. Due to these kind of issues, ladies and gentlemen, we have an intermediate layer, which we typically call the gateway. Here's a gateway. Gateway is trying to solve this problem. it's going to control all the things. Typically, gateways are connected directly to power. Connected typically directly to power. These are not typically battery powered, typically connected to power, right? Remember in the field example, you have sensors. In the meantime, you have those towers with solar panels. Those are gateways. Gateways will connect all the sensors and talk to internet in a unified protocol. Now our problems are solved. No more multiple messages, no more security threats, no more different protocols, no more power problems, no more power issues, but the gateway is going to take care of all these problems. I hope this is making sense now. It's becoming much more sense to you. This is where we are demystifying IoT, where it's making sure much more appealing to us, where it makes much more appealing to us, where we find that these things are very easy to apply to our day-to-day lives. It's very easy to apply these things into our day-to-day life as well as to our businesses. Now, I talked about different types of connectivity options. Let's talk a little bit about these connectivity options. See, as the slide says, it has three different connectivity methods. What are the three different connectivity methods? First one itself is the section where you need high bandwidth, right? You need high bandwidth. You have high power requirement. You have high range requirement, and you have high need for bandwidth. Bandwidth means how much data can you send. The typical best example is your mobile phone. Typical best example is your mobile phone. You get your mobile phone, right? You can send videos, high bandwidth. You have high range. You can probably talk in anywhere in the Sri Lanka, anywhere in the world using your mobile phone. Pretty good range, high range. And also it consumes a lot of power, right? You need
Recording in progress.
Wi-Fi range goes out of range, and it's pretty limited. Bluetooth is pretty limited. So these are the ranges, these are the internet, these are the connectivity options that you need when you need high bandwidth. So I'm talking about, ladies and gentlemen, here about the dilemma of the fight, the fight between these three things, a match between these three things. And obviously there's the third option where you need low power, the low power and high range situation, low bandwidth. You don't need to have a lot of data to send, right? Imagine a sensor. Sensors, let's say something like a typical soil moisture sensor or a temperature sensor. It doesn't have a lot of information to send. It's just needing to send just a number saying my temperature is 37 degrees Celsius. That's it, just a number. Not a big number, not a big data, just a simple number. And you need to just send this number probably every 10 minutes. So the latency is okay. The data content bandwidth is not enough. It's pretty low. But power should be absolutely minimum. You can't spend a lot of power to send that information. And also, you need a lot of range to cover. I'm talking about sensors. Remember that paddy field, you need to have low power. You need to cover entire paddy field, high range, as well as low bandwidth. Not that enough, not much of data. This is where low power communication protocols come into play. You may have heard of things like Zigbee. You may have, there are better things coming into the arena field, like low power WAN, low power wide area networks. LPWAN represents low power wide area networks. Then we are talking about NB-IoT. It's an upcoming technology, a low power, high range capability. And then we have things like low range wide area networks, which we typically call LoRa or LoRaWAN. Now, these are typical options that you have when you are talking about connectivity in your IoT system. Typically, when you're talking about connectivity in your IoT system. So if you again go back to our diagram, our simple diagram of IoT, here is our simple diagram. And this is the exact place that we want to talk about these different types of connectivity. So here are sensors or hardware devices, now you understand pretty clearly that these hardware devices need high range, right? These things need, let me write here, these things need high range, right? They need high range and they need to be low power. They need to be low power and typically low bandwidth, right? High range, low power and low bandwidth. But what about the gateways? So before going there, probably you may be selecting ZigBee here, or you may be selecting custom RF. I can remember one project that I did, the IoT, it was a display that I did. I talked about that display. We were using custom RF. We were using custom radio frequency. We developed our own protocol, radio frequency protocol to talk to our gateways. So in our example, Zone 24 is an example, connection from here to here was from a custom RF channel. We used a custom chip, custom RF channel, but you could have easily used ZigBee. At that time, ZigBee was too much consuming power to us. That's why we used custom RF. So you could have, nowadays you have things like IoT, NB IoT, which seems ideal. And that's the selection of communication channel for that range. But then you have the gateway, which collects all information and go to the next level of sending those things to the cloud. Probably you may use Ethernet, or probably you might use things like Wi-Fi to send that information, because gateways are typically powered devices. In our example, the typical display example, our project was to put up displays in a large warehouse, not a warehouse, it was a big supermarket chain. And we were supposed to put displays in different parts in this warehouse, in the store, where these prices will be updated. You call it e-signs these days. These days you call it e-signs. In fact, we did e-signs even before e-signs come into the market. These were called e-signs, and we did this for a supermarket chain for a Fortune 500 company. And these e-signs were again based on IoT concept. IoT word was even not there, but they connected through custom RF to a gateway. Gateway was based on, if I can remember, a custom board that we designed based on a certain processor. And the connection from the gateway to internet or the cloud was based on Wi-Fi, because gateways were fixed on the roof of the store. There were about, if I can remember, about 500 e-signs or 500 hardware in the store, where there were 2 gateways to handle all 500. You understand, then now you have limited number of gateways, but large number of hardware. And our selection for communication in the gateway level was Wi-Fi. Let's talk about the next section, which is the cloud server. Now, why do you need cloud, right? Why do you need cloud? It's typically brilliant to think of the internet. If you think of 1970, ladies and gentlemen, if you think of the area of 1970, you may have heard of things like, 1970, our people, engineers, they had to rent time in mainframe computers. We didn't have things called personal computers. These days, we had to rent machines based on time. We had to rent a time in a mainframe computer. Only government or universities were could afford a computer called mainframes. We needed to rent time on a machine. That's 1970. But the times change. Then in 1980, personal computers came into the picture. As a result, here we are, everyone in the world now has a computer during 1980. But you can see now, if you look carefully, things are again changing and going back to that early dilemma where we have now again started of renting things. We are again renting. Can you see that we are again going to the backstage and renting again? We are talking about AWS, where we are renting server space. We are talking about Amazon Web Services, where our servers are not anymore physical servers like we used to be. We are renting servers. We are renting space. We are not anymore. We are buying storage devices like hardware, hard disks. We are renting storage. I mean, think about you and me. We don't anymore download songs. Anytime we need a song, we just go to YouTube, Spotify. I listen to these things because there's no need. We just rent songs. You don't need to download movies anymore. You just go to Netflix and watch any movie that you like. You don't need to keep your files on your hard disks anymore. You have Dropbox, you have Google Drive. All my photos are backed up to someplace. All my devices, files, everything is backed up to something. So everything is in a rented place. The times are again changing to the back, ladies and gentlemen. There's now no need for you to have your own physical devices. So the things are changing. With this change, we are talking about going back to the early situation. That's exactly why we are talking about going back to the early situation. And this is exactly the situation why we need to ask the question, why we need cloud. Exactly the point why we need to ask the question, why we need cloud. Pretty interesting to know. Why do we need cloud? And it is exactly evident, self-evident. Why do I call it self-evident? Because of a simple reason, because it's giving us a decreased cost. Imagine the cost if you are having your own personal private storage. If you have a large amount of data to send or to store, having your own storage system with lots and lots of hard disks are not going to help. For example, let me give you an example. We have a system which is doing video surveillance. You have video cameras all around a certain building, get video data from everything, analyze the video data, take actions based on this video data. Just like that burglary example that I was talking about. You analyze all the video data that are coming and act upon that data. That's going to take a lot of money to you if you start saving all those video feeds in your local hard disks. Absolutely not going to work. Absolutely not going to work. And also, what about power? What about availability? What about the processing capability? It needs GPU to do that processing, and it's not going to be that easy. You need to spend a lot of money to do that. But now the things are changing. You don't need anymore to pay for whatever the devices that you go, because you can simply do what? You can rent the things. And the beauty in that is you don't need to even pay for the infrastructure. What does that mean? You can pay only if you use the systems. If you are familiar with Amazon Web Services, you know majority of the things you will be paying only if you use that. How cool that is. You are paying a system, you are paying infrastructure only if you use that. Makes sense, isn't it? It makes sense. That's exactly what we are talking about here. That's why we need cloud. And also, very importantly, cloud or internet provides us high scalability. You can scale your system absolutely as you need. Today, your business, let's talk about a little bit of business. Your business at the moment, let's say you have a business of video surveillance, right? You may be having only 100 cameras for today, right? You may be having only 100 cameras, which means you need about, let's say, 2 terabytes of hard disk storage. Suddenly tomorrow you get another business, you increase this to 1,000 cameras. How much space do you need? Probably 200 terabyte. Are you going to buy 200 terabyte? If you are buying 200 terabyte, how much money is going to spend? And can you guarantee scalability? Scalability from 2 terabyte to 200 terabyte to 20,000 terabyte is going to be a different story. And how can you make sure that all these devices are available every time? And that's the next beauty. You talk about these all cloud service providers, they are going to guarantee you a lot of availability. It's going to guarantee you like 99% availability sometimes. Sometimes you will be amazed to see some of the cloud service providers are giving you availability like 99.999999 up to 7 nines of availability. Sometimes up to 11 nines of availability. It means the services are that much trustworthy. The whole point, ladies and gentlemen, is that the cloud is becoming much more powerful these days, much more trustworthy, something that you can really trust, something that you can really, really trust. This is exactly why we are saying that these things are absolutely things that are doable. So if you think of your IoT architecture, things are now much more making sense to us, because you have your IoT systems where you have your hardware, where you have gateways, and things are connected to your cloud. And it's a simple thing then, using your whatever the applications where you can get meaningful data. You can connect your mobile applications, you can connect your dashboards, right? You can connect your web applications, you can connect anything and everything to cloud and take meaningful decisions. Pretty simple thing. So here you are talking about high level applications, but go back, you're talking about low level applications. Just taking one few minutes in our schedule, I'm going to quickly talk about your next career opportunities here. You see here that IoT gives you a lot of opportunities for you to work on different types of careers. See, you have the ability to work in high level application development career, like here, in mobile applications, dashboard development, UI, backend, high-level application development stage, or you can be even talking about this level where you are talking about networking level, making sure that things are getting to the cloud level. Probably you may be interested in talking at the gate level, gateway stage, or you may be a guy who is interested in the lowest level applications. Someone like me who likes to always go to the bottom of the things, talk about hardware, talk about protocols, talk about low-level languages, talk about real low-level stuff. You may be someone who likes high-level stuff. As and things are needed, there are different career opportunities in all spectrums of IoT. It can be high-level application, it can be a low-level application, it can be internet connected thing, it can be data connected thing, it can be security, it can be about data analytics. So if I give you a few examples, there can be embedded systems coming into the picture, there can be software engineering coming into the picture, there can be security coming into the picture, there can be data analytics coming into the picture, things like big data coming into the picture. Especially there are things like machine learning, artificial intelligence coming into the picture, because you need to analyze the data that's in the cloud. There are machine learning, artificial intelligence coming into the picture. There's, if you're talking about the lowest level stuff, there's mechanical engineering coming into the picture, right? There are other things like low power designs coming into the picture. So we need designers. And here we are talking about other things like user interface designers. If you are great in your artistic nature, and if you are a person who is interested in testing quality, you have quality assurance here. You have different sections. If you are interested in networking, you have networking here, DevOps here. You have the entire spectrum of careers. Opportunities are there. So what I'm going to say is related to what we are talking here. Opportunities are everywhere. Opportunities are everywhere. There are a lot of opportunities related to IoT. It's just a matter of you proving what your expertise is. If you are proving what your expertise is, ladies and gentlemen, there's enough and more than enough opportunities in the market. That's for sure. And I'll be helping you to talk more about the opportunities. Make sure that you put your questions in our little web link that we have shared you. Any questions that you need, because in a few minutes we'll be talking about the questions and answers, and we'll be helping you with any questions that you have and how you can apply your questions in the IoT arena. And just to wind up the things, just to summarize the things, IoT is something that's really going to be absolutely actual. It is reality now. It's no more a magic. It's no more a dream. It's already here. And you can't say now, whatever the field that you are in, you can't say, excuse me, you can't say that you don't know IoT, or you can't say that you are not from engineering, you are not from tech. Excuse me. It doesn't mean that you are from tech you need to know about this because these are now typically generic things. Having said that, here are my communication methods. Here are my communication details. Excuse me. Contact details. You can contact us at any time because we will be readily available to support you, to serve you. I'm in a personal mission to serve people as much as possible. I have a personal mission to help at least 25,000 people finding their perfect career before I reach 40 years of my age. That's my personal mission. And I love this quote about complexity. See, how we started this discussion is talking about complexity of the things. But now I believe complexities have shown you glimpses of simplicities. If you need to think of things which are complex, your job is to make sure things are complex, things are simpler than they are. So instead of becoming a person who talks about problems, I want you to be a person who talks about solutions. I want you to be a person who talks about things that can do instead of things that are real problems. So be a person who is a problem solver, but not a problem creator to this world. Talk to me at any time, send me a message, send me your love, and find me in social media. You got my hashtag. And also, if you are interested, I have a YouTube channel that I generally talk about career opportunities, career guidance, and helping young blood like you finding your first job. How do you find your passionate career? How do you find if you are in the right career? How do you find the career that you want? I call it college to career. If you're a student, you may be interested in that, but that's in single language. Having said that, we have spent quality time with you. Thank you very much for this wonderful audience. I want all of you to put a thumbs up if you found that this session gave you something that at the end, it feels like that you have clarity on things and you can ask some real questions. Thank you very much. There are a lot of people raising hands. I love this audience. Thank you very much. I love this fantastic audience who is absolutely gorgeous, absolutely loving, absolutely intense with me and so live. And I'm pretty sure that you are pretty energized. I'm energized. I'm feeling your love. I'm feeling your connectivity. I'm feeling your abundance. Thank you very much for liveness. Thank you very much for this interaction. I love you all. And with that, I'm going to finally say, let's make sure that this world becomes a much more better place than how we found it. With that note, congratulations for doing this. Congratulations for being here. You have few more sessions as instructed by our MC. There are few more sessions coming in few other days. You may get more information. Make sure that you hit that connections. Make sure that you are hitting that Facebook page and make sure that you're connected with this series of things and make sure that you attend the final competition. That will be a real challenge. Especially, it might be the first challenge that you do. It might be the first opportunity for you to solve a real world problem. So having said that, things are not anymore dreams. Things are not anymore magic because dreams are not those things that you see when you are sleeping, but dreams are those things that do not let you sleep. Thank you very much. We'll catch you again in Q&A. Before going there, control goes back to our wonderful MC. Thank you very much.
Thank you so much, Mr. Tirina. I think it was such an interactive session with you. I think you made engage with us. And one thing I picked from your content was that anything is possible, but that means it should be there. A lot of sweat should be there. So it was a nice point to me as well. So, Mr. Tirina, let's switch on to the Q&A session. So, the most quoted question is, Mr. Tirina, what are the jobs available on the IoT field?
I think I touched upon that at the end, but that's an interesting question as I touched upon that at the end of the thing. But I like to bring a different perspective to that question. Thank you for that question, by the way, for all the people who asked that question. Now, as I said at the end of the session, the jobs are varying. You have three options there. I said you have the lower level stuff like me, electronic engineering, the software, the firmware side, going into the lower level of firmware side, designing radio frequencies, designing hardware, low power designs. These are low level stuff. Then you have the high level stuff like application developing, analytics of data, big data, machine learning. These are high level stuff. See, remember you have the two edges, right? These are the low level things. These are the high level things. Now, nothing is superior to another thing. I'm not saying that this section is high level things are better than low level. No, 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 no. It's what you love to do. Now, I love to do left things as well as high level things. At the moment, I'm a consultant and I'm handling the entire spectrum. But you may like to start from the low level stuff. I started from the low level stuff. You can be an electronic side, you can come from firmware side, you can come from low level firmware development side. You may be interested in hacking operating systems. Those are some of the things. On the high level stuff, you have other things like machine learning, data science. What do you like to do? And in the between, you have other things like testing, networking, DevOps, connectivity between things. So you have basic 3 opportunities, my friend, if you're asking that question. But I'd like to just give you one more point. Now, here's the misconception about IoT related careers. One, I have seen a lot of people applying for IoT related jobs and they think that IoT related job means designing robots, connecting always with robots, playing with robots, working with hardware, sensors. Well, that's true, partly true, because now you understand that putting sensors is just one part. Making the robot is just one part of the total ecosystem. So IoT jobs doesn't mean always that fun things, fancy things that they show in videos. It's not only that fancy things. It has underlying sweat. If you are engineer, if you are coming from engineering background, there's underlying sweat that typically are not shown in the promotional videos. So when you see a robot, it's not just the fancy robot that we are talking about. There's other fields that are making that robot going. So make sure, ladies and gentlemen, since you are the young blood, know this, the reality is not always the fancy things. There's underlying deeper technologies that are attached to these careers. If you want to get the real crux of the nature, be ready to go much more deeper into the equation. The real beauty is not at the tip of the icebergs, my friends. It's at the bottom of the icebergs. I hope I answered that questions enough.
Yes, and we have another person, Mr. Vipula, is interested with us to join the Q&A session. So, Mr. Vipula, you can join the virtual platform too.
Hi, Vipula.
I think you are there, Mr. Vipula. Yeah, until Mr. Vipula joins us, I have another question. The question is, what are the qualifications that Zone 24/7 consider when hiring for IoT-related jobs? Is that enough to any IT-related graduate? If not, what degree programs you are going to accept?
Okay, it's true I'm coming from my Zone 24/7, but let me talk more generally related to all IT field jobs available. So this is true for Zone 24/7 as well as this is going to be true for any other IT related organization, whether they are working in IoT. They might not call that IoT because you understand now there are 3 things: low level stuff, high level stuff, middle level stuff. They might not call IoT. They might not even know that they are doing part of IoT. They might call you data engineers. They might give you different title. The title doesn't matter. Qualification as per se, here's one thing I would say to a new graduate. If Vipula is there, he may add more. The first and foremost thing that I can give you is, the best advice that I can give you is, you may not know what's the latest trend in Java. You may not know how C# works. It's a majority, it needs to be done. You may not know the syntax by heart, but that's okay. We can teach you those things. But we need people who are good in fundamentals. Fundamental engineering is a must. When I say engineering, it's not the engineering degrees. It's the fundamentals in anything that you follow. It can be an IT degree. It can be even not related to engineering or not related to technology, but whatever the subject you are doing, the fundamentals is critical. because industry is not going to teach you fundamentals. Industry is going to teach you applications. If you don't know Java, that's fine. We can teach you Java better than the university most of the time. We can teach you C++ better than them. But it's difficult for us to teach you fundamentals. So we expect fundamentals from the graduates, from the undergraduates especially. And the second thing is be passionate about whatever you're doing. That's why I showed you there are a lot of opportunities. If you are truly passionate about something, ladies and gentlemen, you can do that. And you won't even worry about the salary that they are paying. You won't even worry whether they are giving you a survival share, because you are passionate about the things that you are doing. It's not about the love that you have for the company. It's about the things that you are doing. Are you passionate about things that you are doing? Are you okay to sit in front of a computer and type code? If you are passionate about that, become a software engineer. If you can't do that, if you are not passionate about typing code, but if you are passionate about working with MATLAB, coming up with a quick MATLAB model, you may be interested in research. And if you are good in art, if you want to get into this IT field, maybe you are going to be a UI engineer. So the second advice is find what you are passionate about. What's passion? Very simply, this is my way of defining passion. Passion is something that you can do skipping your meals. If you can do something, and by doing that, if you forget your meals, if you forget your breakfast, if you forget eating, that's your passion. If you can do something without eating, that's your passion. And if you can code without eating, and if you don't get hungry, that's your passion. Find a career in your passion, not the career that pays you more. This is related to Zone 24/7 as well as to any industry. So the answer to your question is, we don't care whether you are coming from a particular university or you are coming from a particular degree, as long as you are passionate about what you are doing, as long as you know the fundamentals. I hope I answered the question. Thank you for that question, by the way. Very valid question and a very common question.
My next question goes to Mr. Vipula. So the question is, how is Sri Lanka taking steps to develop power system with the use of IoT? Could you elaborate with the use of smart grid concept?
All right, so it's a good question, but I'm not the best person to answer because I'm not coming from that area. Okay, so I know that from our electrical distribution side, the government and the electric companies are doing some stuff based on especially electricity usage and metering and monitoring, right? There are certain projects that's currently happening in the suburbs of Colombo. But I don't really have a good understanding on to answer that question at deep level, unfortunately.
Yeah, and the next question is, Mr. Vipula. So what about the risk of IoT and how can we manage those?
Right. Again, nice question. So if you have, there are so many movies, if you are a movie fan, there are so many movies where we talk about IoT going wrong and computers and machines coming and taking over people. So it's up to your imagination. There are so many places where IoT can go wrong when and if we start trusting the machines more than what we should do, right? We should be, the machines will be dependable to a level that we can depend on them. But if we start over depending on machines at some point of life, they can become a threat to people. And again, because we are dependency. If you're, for an example, these days we are dependent on, some people are keeping their life dependent on machines, right? During COVID situation, many people are giving their lives to machines, right? So those machines are created in a way that to a level of to keep that person alive, but it does not really replace a doctor. You probably get my point, right? So we need to put the machines in the right place as long as we follow the simple rules. I don't think IoT is going to be a threat at all, right? So again, up to your imagination.
And my next question is to Mr. Tirina. The question is, sir, what are the methods of gaining capital for further development of our project and how to choose the right investor that suits our vision?
Well, brilliant. These questions are absolutely brilliant and mind-changing problems. It's about finding capital to your projects. At the starting stage, I won't say that you need to talk to investors and talk about your ideas, because they might ask you certain questions where you don't have answers. For example, what's your ROI? What's your next financial planning? What's your return of investment? What's your exit strategy? You might not sometimes have answers to these questions if you go at a very early stage. So probably what I have seen and what I have even done is to go for pardon me saying this, but we go for 3 F's people: family, friends, and fools. Let me say that bluntly. At the initial level, you find capital through family, friends, and fools. Don't get me wrong, but these are the 3 F's where you find capital at the very first level. You get your systems up and running at the very early level. You bring it to a certain level that you can generate results. And then you start approaching people and they show you, here's the results that we can get. Here's the exit strategy for you. Here's the return of investment. Would you like to invest for us? Now, saying that, you have a brilliant opportunity now, because in Sri Lanka, you have a lot of funding options. You have things like Lanka Angel Networks, looking for opportunities to invest. You have a lot of angel investors within Sri Lanka. If you search for opportunities, investing opportunities, you may find there are a lot of opportunities. ICTA is giving you opportunities. The government is also investing in small scale startups. Startup ecosystem, that's a website called Startup LK, where you can register your things and where you can apply for money, fundamental capital. So first, my suggestion is, bring it to a certain level where you can talk about return of investment, exit strategies, and where you can show returns, where you can show output in the long past, in the next future, few months to come, few years to come, then approach those funding options. First, have the clarity in yourself, then talk about money. It's important that you first find your capital first through that 3 F's that I mentioned, and bring the systems up and running. Make yourself clear about the final output, then approach the available options. So I want you to see Startup SL. I want you to see the Lankan Angel Network, and there are many other investment opportunities, especially investors, angels, who are right there ready to help you.
I'll ask this question to combining 2 questions. So the question is, so what is narrowband IoT and what are its application? And the next question is, what is ZigBee?
Right. So I talked about a lot of communication methods. One communication method wherever you need to send low bandwidth, which is low data, but cover a long range with low power. If you need low data, send small data packets and long range and with low power. If you need that, then you are talking about NB-IoT, or you are talking about ZigBee, or you are talking about custom profiles. If you really understand, this is where bottom hardware sensors will talk to gateways. So NB-IoT, and if you want like ZigBee or custom RF, these are all possibilities where you can send small amount of data to a larger distance and having a very small power option. NB-IoT is pretty new, and narrowband IoT, NB-IoT we call it. It's a pretty new thing, not that pretty new, but it's new to Sri Lanka at least. ZigBee is pretty easily used. There are a lot of chips available in ZigBee world. Sometimes they can range. I can remember ZigBees were available which can send information to up to 7 miles, even farther than that. We used a custom chip called, if I remember, CC1101 for our project, our product that we used for sending information, and it could send information to about 100 meters with 2 pentorch batteries. Remember, with 2 pentorch batteries, 2 AA batteries for 4 years. That's the power that we use. So don't worry what to use. It all depends on what you want to get. ZigBees are typically consuming a little bit more energy. If you need absolutely low energy, you need to go for CC110111 0-1 like custom RF mechanisms, or you can use even low power designs, low power communication protocols like NB-IoT or ZigBee. So basically the understanding is these are all hardware level to gateway discussing or communicating channels, low power channels.
So this will be the last question for the day. So I request all the participants to stay until the end because the most interesting competition will be announced very soon. So the last question is open to you both, Mr. Thilan and Mr. Vipula. So the question is, sir, I like to do self-study and more deep into IoT handling, especially about ESP Wi-Fi modules. Can you suggest a good source that I can learn?
Was that related to ESP? I think Vipula, you can take account.
I can give you some references, but I think Thilan probably also this particular module, right? It came some few years back. So it's a very powerful module that has a microcontroller and RF interface plus the full TCP/IP stack on it. So if you want to just develop an application on top of that, there are so many, like even the Arduino forums can help you immensely. It has Arduino programming interface. But if you want to really learn what is happening inside that chip, right, you have to go to the datasheet and deep level. And I have seen there are certain forums at electrical engineering level where these discussions are happening. So it all depends where you want to learn, all depends on what you want to learn. Tirina already explained that. So really it can be part of these Arduino forums if it is just you're trying to develop an application. And if you really want to go into the like hardware level details, it's a very powerful chip. If you have big ESP chips for your project, it's a very powerful chip. Only thing is what you can do with the chip is immense if you touch that chip in the right place. So it's a Chinese chip, so you may not find a lot of information like you find about an Intel microprocessor or microchip. Mostly the data is available through forums. Till am I correct? So what's your?
Thanks, Vipula. I think the way I generally talk to when I'm talking to non-engineering students, they might not come from programming background. So in general, if you are talking about a person who doesn't have many programming background, that doesn't have a programming background, I would generally encourage them to start with Arduino before even going to ESP32s, ESPs, because it's pretty simple, English-like, where you might know a lot of programming knowledge, but that is something inevitable. You need to have programming. But if you need to start all the IoT related work, I highly encourage starting with Arduinos, as Vipula mentioned, and then you can slowly move into ESP32s, ESPs. ESPs are pretty basics, as well as they are pretty advanced. You can do many things. So if you ask, for example, from us, whether for this particular project are you going to use this microcontroller, that microcontroller, Vipula might it's not a simple decision, it's going to be a complex decision. So there are many platforms available. You can start with Arduino. You can typically buy ESP32 modules, pretty cheap, these things. And also you don't need to even do programming on most of these devices. You have visual programming tools nowadays available. If you don't know programming, you can start with visual programming, get into the logic world, get into the world of programming by visually doing these things. Arduinos are going to help you. Get into the forum, start talking, start doing these things, because the beauty is resources are already available in the internet. Now you can't complain that things are not available. I mean, even for projects, I can guarantee that most of the final year projects that you are thinking at the moment, they are already done somewhere in the world. It's very easy. These things can just copy paste and make things available. So I would encourage, just like Vipula mentioned, start with Arduinos if you're pretty new. But if you want to go into the next level, go into the crux of the material. Learn embedded systems, where you go inside the microcontroller and learn how microcontrollers works. That's what I'm talking about, fundamentals. If you are from the embedded systems background, maybe then you start talking about more into microcontrollers versus microprocessors. You can think about ESPs, and microcontroller wise, you need to learn a little bit more about the data sheets. That's where you have specific embedded systems knowledge specific smart systems knowledge come into play. So my suggestion is start from simple things like Arduino, visual programming if you are new, and then slowly emerge into ESP markets and other complex things. But one simple example is you start with Arduino, using Arduino level, and then move into learning about the Atmega 325 chip, which is embedded in the Arduino Uno board. Arduino is powered by most of you know by a microcontroller called Atmega 325. Take that and try to program that using C. That may be the next level. So this is progression. And if you are new, start with the bottom. If you are pretty advanced, start at the relevant level that you are. I hope we answered your question.
Yeah, thank you, Mr. Zilla, and both thank you, Mr. Vipul. I think it was so interactive and it was very informative and interesting for us. So, Tamira.
Yes, Asir. Thank you, Mr. Thiline Yapabandar. That was a wonderful session, and I think you get a better idea about this session. So now it's time to get to know what happened to next in InnovMind. So I invite the co-chairman this project, Manula Rajapaksa, to keep you informed about the future movements of InnovMind. Manula, it's up to you.
Hope I'm audible.
Yes, Manula.
Okay, so hello everyone, and first of all, thank you for staying this long. And I really think that this session was really interesting, and the way you have been interacting with us. And I hope, I'm pretty sure that everyone here are interested in like taking part in the other sessions which are going to come in the next few weeks. And you know, the second phase of InnovMind will be the workshop series. And so without taking much time, I would briefly explain what we are planning to do in the upcoming weeks. So tomorrow we'll have the first workshop of InnovMind series, which is on the topic, how do I choose the best hardware for my IoT project? And we'll be having Mr. Ushan Shaminder, lead explorer and CEO of Gavesha Labs Private Limited, as the guest speaker. And on the 25th of September, we had our second workshop on the topic, engineering product design, process, and prototyping. And that will be led by Mr. Ranjan Kulatunga, senior design engineer at Zone 24/7, along with Mr. Niroshan Karunaratna, tech lead at Zone 24/7. And on the 26th of September, you will be able to join the third workshop on the topic, software architecture and IoT. And it will be conducted by Mr. Isuru Samarasinghe, staff engineer at Nagaro. And the final workshop will be conducted on the 3rd of October on the topic, cloud IoT. And it will be done by Mr. Shamira Prajapia, founder, CEO of Impact IT Solutions, who is also a principal architect and a Microsoft MVP. And also, you know that we'll be having our competition, and I kindly ask you to stay in touch with us in our social media and all the WhatsApp groups. We'll update you with the latest information about our projects. So stay tuned with us. Thank you very much.
Thank you, Manula. So in order to officially conclude the event, I invite the project secretary, Chehani Jayasundara. So Chehani, you can have your chance.
Yes, very good evening to everyone who are present here today, participating in the introductory webinar of InnovMind. It is such a great honor for me to get this opportunity to thank all the dignitaries. On behalf of the organizing committee of InnovMind, I would like to express my gratitude to all the esteemed delegates of the introductory webinar for their presence and also for their immense contribution to make this event a success. First and foremost, I would like to express my gratitude to our honorable guest, Mr. Thiline Yapabandar, for the delivery of a wonderful and also fruitful session about IoT. Sir, thank you for the great insight that you shared with us today on IoT. And I also hope, and I definitely know that all the participants today were greatly benefited by your thought-provoking and also this interesting introduction to the field of IoT. I'm also utterly grateful for Mr. Timit Pereira, the chairman of IEEE student branch of SLTC, Mr. Sassi Sendra, the chairman of IEEE IES chapter of SLTC, and also Mr. Sarinder Shehan, the student advisor of Project InnovMind, for the great support and assist rendered to us. I thank their minute-to-minute support and guidance for encouraging at every point of time in organizing this event. Next, I would like to express my most sincere thanks towards Zone 24/7 for gracing this event as our platinum sponsor. Mr. Vipula Lianarachi, the General Manager of Zone 24/7. Thank you, sir, for sparing the time from your schedule to grace this occasion. Without your generous financial support, we wouldn't have been this successful today. Last but not least, I must also thank the organizing committee of the Project InnovMind for their great efforts to make this event a success. I would also like to thank the moderators of Tamira Ganchaya for their effort towards great anchoring. As this is just the beginning of a wonderful series of webinars, I invite you all to join with us until the final phase of the mind. And thank you once again for everyone for making this event a success. And also we have prepared a virtual token of appreciation to award our honorable guest speaker, Mr. Tilnyapa Bandara. Sir, please do accept this.
Thank you very much. Thank you.
So Tamira, you can take the chance.
So, okay, guys. So thank you for joining with us these wonderful sessions. We hope you will join our next sessions and next our co-chairman mentioned for InnovMind next sessions. So thank you for joining with us today. I am Tamira Dhananjaya. So Hazira.
Yes, and I am Hasira Mahel. So stay safe and stay healthy and join with us for more enthusiasm. Thank you and good night.
Thanks all. Good night.